week, Lab TV travels to an Army research lab in Natick, Massachusetts, where scientists are creating very tiny antennas inspired by one of nature's most beautiful creatures, the Luna Moth.
The Luna Moth can actually locate a mate when the mate is miles away by having this very, very, very sensitive antenna. The female moth actually emits an electromagnetic pulse that's in the IR.
The female sends out an IR, or infrared light wave, and the male's antenna is specifically designed to receive that signal.
The antenna actually collects the light and it directs it towards a probe that's at the base of the antenna. And then that probe sends a signal to the brain.
The moth captures infrared light. Brian and his team are working to capture visible light. Infrared is measured in microns. Visible light is smaller. It's measured in nanometers.
Nanometers are usually compared to a human hair. So you could have, say, tens of thousands of nanometer-sized features around the circumference of a human hair. And the really interesting thing about nanotechnology is that because these features are so small, these materials interact with nature, with light, or with sound, or with really anything in new ways. With light, it turns out that nanoparticles are very, very useful because nanoparticles have sizes on the order of a wavelength of light. They interact very strongly with light.
Visible light waves are very short, only 400 to 800 nanometers. Radio waves can be longer than a meter.
If a radio antenna is, say, half a wavelength of a radio wave, you get a very, very strong coupling of that radio wave into the antenna. The same thing happens with light. So if we can make a nano feature that is on the order of a half of a wavelength of light, then we get this very, very strong interaction.
Brian is making tiny antennas that are tuned to receive light waves, just like your car antenna is tuned to receive radio waves. He's making them from carbon nanotubes.
So a carbon nanotube is really a rolled up sheet of carbon. The interesting thing about carbon nanotubes is that we can control their length. And because of that, we can tune them so that they interact with specific wavelengths of light.
In nanotechnology, the best way to study light is with lasers.
So lasers are a very useful way of studying the interaction of light with materials because they are very, very controllable. You have this very, very intense light source that's highly focusable, that goes exactly where you want it to go, and it's all the same color. So now we know that a material, let's say, interacts very strongly with a red color, or a green color, or a blue color. We can choose our laser so that it interacts very strongly right at that particular wavelength. If you illuminate these nanotubes, and if they are the right length, they'll actually couple very, very strongly with light. And with coupling like this, you can actually get near 100% coupling of energy, which is highly, highly efficient. So now the question is, how do we take that energy and do something useful with it?
They have lots of ideas, like converting solar energy into electricity.
We'd like to be able to make a connection between light and an electronic circuit. So we'd like to be able to turn light energy into an electrical charge.
Brian and his team are pioneers in a brand new field. They have a long way to go, but it's very exciting work.
Probably one of the most exciting things is that when we're evaluating some of these materials, many times the response that we get is not at all what we expected. And what I found is that many times what it really is doing is a heck of a lot more interesting than what you actually thought it was going to do. So that's, I think, is one of the most exciting things, is you really never know what you're going to see.
To find out more about light, antennas, and nanotechnology, check out labtvonline.org.